Welcome back, Math 30-1. Today we are looking at sinusoidal functions. Now, what is a sinusoidal function? Sinusoidal function is just a graph that resembles a sine or cosine curve. Okay? And it is something that occurs in nature. It's a phenomenon that occurs in nature in periodic ways. So examples of this are sunrise, okay? Day of the year, the height of a chair, of a Ferris wheel, and maybe the time of depth of an ocean during the tides. So those are going to be the main questions we look at. Sunrise versus the day of the year. Sometimes it's even weather cycles in the day of the year. We look at a Ferris wheel. Quite often on your diploma they'll have a Ferris wheel and chair question. And they also tend to have an ocean due to changing of tides. So those are the main ones we will be looking at. So right here, we're going to go on to class example number 1. It says, the depth in meters of water in a harbor in T 24 hours after midnight can be approximated by the following function here. All right? Now, I'm going to rearrange this function so it makes a little bit more sense to us. I'm going to rearrange this so I have my height is going to be, or my depth is going to be 5 cos 0.5 t, and then I'm going to have plus 12. So my d value is where we kind of want it to be. So now it wants us to find the maximum and minimum depths of the water in the harbor. Well, my maximum minimum, that's going to be my distance from my midline or my vertical displacement, which is going to be my amplitude. So my max is equal to 12 plus my amplitude, which is 5, which is equal to 17, and my minimum is going to be the same as 12 minus my amplitude of 5, which is going to give me 7. Okay? Next, it wants us to determine the period of the function. Well, my period, we have to know my b value. My b value is 0.5. So period is equal to 2 pi all over b, which is 0.5, which is going to give me 4 pi is my period. So 4 pi hours. Okay? Next it says, write a suitable window which can be used to display the graph as a function. Well, my window I'm going to say is, because we know we're talking between 0 and 24, I'm going to put as my x value. We're going to look between 0 is going to be my minimum, my max is going to be 24, and I'm going to say a scale of maybe 2, so every 2 hours. Now for my y, I'm going to have here, we're going to look at, my minimum is going to be 0, so no depth. I'm going to put my max at 20 or even 21. And then my minimum and my scale here is going to be of 5 meters. We could even put 2, doesn't really matter. Okay? You could have many other actions there. So let's put this into my calculator. So I'm going to clear that window. So I wanted 0, 24, 2, and here we wanted 0, and I said 21, and I said counting by 5. I'm going to graph it, y equals, and let's put in what we have here. So I'm going to go 5 cosine, and we have 0.5 x bracket plus 12. And make sure I'm in radians, because we're going to be in radians most of the time when we do these, and we're going to graph it. And right there is my graph. Okay. So what is the depth of the water at 2 a.m.? Well, I want to be looking at this here, 2 a.m., and my time starts after midnight, so that's going to be at 2. So I'm going to trace at 2 here. So I'm just going to push trace, and I want at 2 a.m., which is going to be 14.7 meters. So I go trace at 2, because we want when x is equal to 2, and we end up getting my y value is 14.7, so it's 14.7 meters is the depth at 2 a.m. So now E is saying a ship requires a minimum of 8.5 meters of water in the harbor at midnight. So by what time to the nearest minute must it leave to prevent grounding? Okay? So what time must it leave before the water level sinks so much that the ship grounds? So I'm going to look here. We want minimum at 8.5. So I'm going to go here, 8.5, and I'm going to graph it. And I'm going to find my intersections here. So it must leave at whatever time this is here. Because this is midnight is 0, so that's going to be where we're going to leave. So I'm going to go second calculate, and I want to find my intersection. And first curve, go over. First curve is around right there. Second curve, yeah, around there. Guess, around there. And I end up getting 4.69. So at 4.69, okay, so that's going to be my x value is equal to 4.69, but I want to know what time is that. So that's 4 hours and 0.69 of 60 minutes. So I'm going to go, second quit, 0.69 times 60 is going to give me 41.4. So I have 41, so it's going to be at 4:41, and don't need that 0.4, or we could say 4:40 a.m. it must leave by. Okay? Because we could round down. We don't want to round up in this one at 4:42, because, well, then it grounds. Okay? And I want it to the nearest minute, so we're always going to round down, so it doesn't ground in this case. Now it says, what is the next time to the nearest necessary minute that the ship can return to the harbor? So we want to know when it could return to the harbor here. So I'm going to go back to my graph, and we look at it here. I want this intersection right there. So I'm going to go second, calculate, and I'm going to find my intersect, which is 5, and we can return right here, push enter 3 times. I'm going to get at 7.873. So it could return at 7.873 is my x. So I'm going to go, so it's going to be at 7 and what is 873 of 60 minutes? And 52 minutes. So I'm going to round this one up. So I'm going to say 53 because if I come just a bit early, I'm going to bottom out. So I'm going to say at 53 minutes. So 7:53 a.m. is when he can come back. Okay, so let's take a look at class example number 2. It says, in a certain town in Alberta, the time of sunrise for any day can be found by using this following formula here, where we have T representing the hours in the day starting from midnight, and D representing the day in the year. So, write a suitable window which can be used to display the graph. So first thing I want to know is what is going to be my max and min of this graph. So I'm going to look at my max is equal to, well, we have my midline is 6.3, and then we have to add my amplitude to that. My amplitude is 1.79. So we're going to have 6.3, and then we're going to end up going 1.79 above it, which is going to give me a total of 8.03 is my max. Now my min is equal to, we're going to have 6.3, and we could end up going, my amplitude says we're going to be up to 1.79 below that. So it's minus 1.79, which is going to give me 4.51. Okay? Now let's take a look at my x values here. I'm going to start off with x for my window. Well, how many days are we going from? We're going from 0 days to 365 days. And I'm going to count by maybe months, so there's around 30 days in a month, so 30. Okay, now let's take a look at my y window. I'm looking at this here. We're going to start from, well, I go to 4 to that, 4.5, so maybe 1 is going to be my minimum. My max is going to be 10, and we could count by 2s or something. Okay? So use the formula to determine the sunrise for there. So I'm going to first plug this in here. So let's go on. Put this in my graph, y equals. So we want negative negative, make sure you use the negative, not the subtract sign, 1.79, and we're going to have sine, bracket, and I'm going to put another bracket, 2 pi, bracket, and then we're going to go d, so x minus 78, and then we're going to divide that by 365, and 1, 2, 1, 2, oh, 1, 2, 3, 1, 2, 3, and I want a plus 6.3, plus 6.3, and I'm going to graph it. Oh, change my windows. Hold on here. Change my window. So I want my x is to 365. I'm going to count by 30s. My 21, we want 10. My min is going to be 1, and I'm going to count by 2s. Now graph. There we go. So here's what my graph looks like. And we're once again in radians. Okay. So it says, for the use the formula to determine the nearest minute when the sun rose on May 7th, the 127th day. So all I'm going to do here is go trace, and I want, trace value, and 127, and that's going to give me 4.96. So we have 4.96 is equal to y. Now I have to figure out what 0.96 is in terms of minutes. So I'm going to go second quit, 0.996 times 60 will give me 57.6. So really it is going to be at 58 minutes. So it is going to be at 4:58 a.m. the sun will rise. Okay? And now D says determine which day of the year the sun rose at 7. So which days of the year the sun rose at 7? I'm going to grab this here, go to y equals, and we want to know when it rose at 7. Okay? So we're going to go graph, and I'm going to find my thing here. So I'm going to calculate my intersection because I want the intersections of these. So here's my first one. Go all the way over. Enter. I get 54, so it's the 54th day, or 55th day, you might say. So 55, we get day 55, and my other one is going to be, I'm going to go calculate, I want my intersection, and go all the way over. And I'm going to end up getting 284. So the 55th and 284th day are my answers.